section 3.3, we're going to be talking about quadratic functions, and we're going to be defining three forms of the quadratic function. We're going to be finding the vertex, the intercepts of quadratic functions, and sketching the graphs from the vertex and the intercepts. And we're going to be converting from the three different forms that we learn about from one form to the other. So a quadratic function is a polynomial of degree 2, and the shape of the graph is a parabola. So we have a couple of different things that can happen, and let's just look at a couple of different graphs. So our shape is a parabola, and we could have a parabola that looks like this. And in this case, you have here is going to be your vertex, and in this case, there are no x-intercepts. So you notice that the number of x-intercepts is 0, but we could have something like this, where there are two x-intercepts, or we could have a situation where there's one x-intercept, and that's going to be when the vertex is the x-intercept. The y-intercept, it always has one y-intercept. So in this case, this is the y-intercept. It's just where it's the y-axis. In case, let's call this one B here. B is going to happen further up the y-axis. And then up here in C, the vertex would be the y-intercept. And then these parabolas can open upward or downward. So in A, you notice it opens downward. In B, it opens upward. And C, it opens upward. And the vertex will always be a maximum or a minimum. So in A, you notice the vertex is a maximum. In C and B, you notice that the vertex is a minimum. So a quadratic function can take three forms, and we're going to talk about these three forms today and actually be able to write an equation go from one to the other form. So it could take transformation form, and that's the first one I give you. It could take polynomial form. It could take x-intercept form, and in all of these cases, A, B, C, H, K, S, all of these and T, these are all real numbers, and A cannot be equal to 0. The parabola is going to open upward. If A is less than 0 and the parabola opens downward, let's see if I can get this text. I'm sorry, it's going to open, if A is greater than 0, it's going to open upward. And if A is less than 0, then that's when it's going to open downward. Okay, and so by A, we're meaning this value here. And that's going to tell us how the parabola opens. And here, and here. Okay, so in this case, in the transformation form, you've got H and K. This is transformation form because HK is your vertex, and you'll see that in just a few minutes. Polynomial form, you're sort of used to using the quadratic formula in this case. Then in x-intercept form, you've got S and T being your x-intercepts, and that's why it's called x-intercept form. So again, if A is greater than 0, the parabola is going to open upward, and if A is less than 0, the parabola is going to open downward. All right, so we're going to work through these problems, and each one of the forms, there's going to be a formula that tells us what the vertex is, the x-intercepts, and the y-intercept. And we're going to work through that and also look at a graph. So the first one, what I have is just the general equation in transformation form. And we're going to find the vertex. And then after we find the vertex, we're going to find the y-intercepts, the x-intercepts, and we're actually going to work through a real example of this as well. So in the first one that I have here, this is the vertex is going to be the point HK from this equation. So you get your H and your K, and that's your vertex. So when I look over here to this example that I have, my vertex is going to be the point 2, 5. Okay, so notice it's minus H, which causes us to take a positive 2 here. And then we're talking about the y-intercepts. So when you're finding the y-intercepts, let's come up with the equation for this. What is it you know? It's where it hits the y-axis, so that means that x is going to be 0. And if x is 0 and we find f of 0 in this equation up here, then we've got a times 0 minus h squared plus k, which is going to give me a times h squared plus k. So that's going to be the formula for my y-intercept. Here, this would be my formula. So if I use that formula over here In my real example, I've got the value of a, so my y-intercept is going to be a, which is -4, times h squared, and in this case h is going to be 2, plus my k, which is 5. And that will give me -11. All right, so -11 is my y-intercept there. And then for your x-intercepts, what do you know about your x-intercepts? It's where it's the x-axis, so in that case, y is 0. And if y is 0, then we're going to say 0 is equal to x minus h quantity squared plus k. And we are solving for x here. So in this case, I need to subtract k from both sides, and then I get this. Okay, and from here now, still I should have my a in here. I forgot my a. So let's go back and put my a. So once that's there, then I'm going to divide both sides by a. And those cancel, so I get -k over a is equal to x minus h quantity squared. And I'm not so much going to ask you to solve for these, but I am going to ask you to be able to use them in the problem. So now I'll take the square root of both sides, and this has got to be plus or minus. And when I do that, I end up with positive or negative square root of -k over a is equal to x minus h. And now, again, I need to solve for x, so I need to add that h to both sides. So it's going to be h plus or minus square root of -k over a. And that's going to be equal to x. And those are our x-intercepts. All right, so now let's use that in this problem. Remember our x-intercepts. The formula is going to be that x is equal to h plus or minus square root of -k over a. So going back to look at our equation now, here's our equation. Okay, so we're going to use that to find that h, the value of h is going to be 2 plus or minus the square root of -5 over -4. And so then I get 2 plus or minus the square root of 5 over 4, or square root of 5 over 2. I want to take the square root of 4. And you can find decimal values for those to help you in graphing. If you do 2 plus root 5 over 2, then you end up getting 3.12, and then the minus is going to give you 0.88. Okay, so now we can use all this information to go through and graph, or just to sketch this. Okay, so if you were to sketch this, then what it would look like, and I'm just going to do a quick sketch here, is you've got a vertex at the point 2,5. So let's say 2,5 is about like this, and a y-intercept of -11. So your y-intercept is down here, and then you've got x-intercepts as we said at 0.88 and 3.12. So it's going to be something like this. Okay, and that would be a sketch of that one. All right, so that's transformation form, and now we're going to talk about polynomial form. Here we have polynomial form, okay, and we're going to find the vertex. So the formula to find the vertex for the polynomial form is going to be, first you find the x by saying x is equal to -b over 2a. All right, and then once you know what that vertex is, the x coordinate of the vertex, you just plug that in for x to find your y. So you do f of -b over 2a, and that's going to give you your y value. So the vertex ends up being, the x value is -b over 2a, and your y value is your f of negative b over 2a. Now, that might be a little difficult to understand, so let's just try it here. Here you have an example. I want to find the x-coordinate of the vertex. So I'm going to do negative b, which is going to be negative 4, over 2 times a, which is 1. And that's going to give me negative 4 over 2, which is negative 2. Now that I know the x-coordinate of the vertex is negative 2, I'm going to plug that in, find f of negative 2, and that's going to give me the y-coordinate of my vertex. So that's negative 2 quantity squared plus 4 times negative 2 plus 5. And so that tells me the f of negative 2 is going to be it's going to give me 1. Okay, so now I have vertex is going to be at the point negative 2, 1. All right, so there's that example. And now let's look at the y-intercept. So again, just like last time, for your y-intercepts, what do you know? We know that x is equal to 0 because it's where it hits the y-axis. So if we find f of 0 with this one, then we get, we plug in 0 for our x value. We get a times 0 squared plus b times 0 plus c. Well, the 0 is going to knock out this term and this term, so f of 0 is just going to be c, which means that our y-intercept is always just c. Okay, so let's come over and look at our example that I have here. For this example, f of x, my y-intercept is just going to be c, and c in this case is 5. All right, and now let's try our x-intercepts. So again, like last time, for x-intercept, what do we know? We know that y is 0. And if we know y is 0, then I'm going to say 0 is equal to ax squared plus bx plus c. And we know how to solve this. We solve this using the quadratic formula. So this is just going to be the quadratic formula to find your x-intercepts. X is equal to negative b plus or minus the square root b squared minus 4 times a times c all over 2a. Okay, so if we go into this example here and use our quadratic formula to find our x-intercepts, it's going to be x is negative b, which is going to be negative 4, plus or minus the square root of b squared, which is going to be 16, minus 4 times a times c, all of that over 2 times a, and we get this. And now if we want to simplify, we get negative 4 plus or minus the square root of negative 4 over 2. Now you notice at this point that we have a negative value in the discriminant, so square root of a negative number. What that means is that there are going to be no x-intercepts. Okay. And so when we look at the graph of this one, let's think about what we have. The graph, if we're just sketching a graph in this case, we already knew that our vertex was at the point negative 2, 1. So we got negative 2, 1, so that's about right there. And it had a y-intercept of 5. So if we sketch that, you notice that it actually does not have any x-intercepts. So there are no real solutions, no x-intercepts for this function. All right, we've got one more form, and this is the x-intercept form. So for our x-intercept form, we're going to find the vertex first for this guy, and the vertex is going to be the average of these two. So we're going to say s plus t over 2, and that's going to be the x-coordinate. And so when you find the y-coordinate, it's just like we did in the previous example. You do f of s plus t over 2. Okay, so that's going to give you the coordinates of your vertex. Now let's try that in a problem. So the x-coordinate of the vertex is going to be, you add them up. So 3 plus your negative 1 divided by your 2. And after I do that, then I can plug that back in. So I know the x-coordinate of my vertex is 1, so I find f of 1, and that's going to give me my y-coordinate. Negative 2 times negative 2 times 2. With what would that's what I'm going to get when I plug my negative 1 into each of these x values here. And when I simplify that, I get 8. So my vertex here is going to be the 0.18. Okay. And then for my y-intercept, again, I know that for my y-intercept, x is going to be equal to 0. So if x is equal to 0, then I find f of 0. And that's going to give me a times 0 minus s times 0 minus t. And when I simplify that, I get a times negative s times negative t, which is going to give me a times s times t, because a negative times a negative is a positive. All right, so I have that. Now let's go over and apply it to this example I have. If I want to find the y-intercepts, it's just going to be a times s times t. And we know the value of a, so my y-intercept is going to be my a, which is negative 2, times my s, which is 3, times my t, which is negative 1. And that is going to give me 6. It's going to be my y-intercept there. And then the last one is going to be to find our x-intercepts. So for the x-intercepts here, we know y is equal to 0. So if y is 0, then 0 is going to be equal to a times x minus s times x minus t. Here we could just use a zero product property, and we know that this means that x minus s is equal to 0, or x minus t is equal to 0, which would tell us that x equals s and x equals t. So those are going to be our x-intercepts. So the point S0 and then the point T0 are going to be our x-intercepts. So let's try that on this example that I have. So your x-intercepts, we notice that the value of, in the first one, the value of S is going to be 3, so we've got the 0.30, and then the value of T is going to be negative 1. So these are our two x-intercepts. Okay, and there we have those three examples. And now the next thing to do is to work between the two different forms. So I'm going to pause here for now, and then we'll pick up on another video talking about the two different forms. You will find that you have a summary of this information at the end of your packet, and I'll actually, let's go ahead and look here. So this is your last slide. Everything I've just talked about is here, and this is a summary of it. So if you, these are all the formulas for each one of the forms. So you notice we covered first the transformation form, then the polynomial form, and then the x-intercept form. We found the form, of course, the vertex. We found the x-intercepts and the y-intercepts. And I was showing you how to get each one of these formulas, and then I was showing you how to apply them to an actual problem.